In this video, we'll write the balanced net ionic equation for K3PO4 plus CuNO3 2. This is potassium phosphate, and we have copper 2 nitrate here. The first thing to do in writing net ionic equations, we need to balance the molecular equation. So I can see I have 1 copper here and 3 coppers here. So I'm going to put a 3 in front of the copper 2 nitrate. Now the coppers are balanced, but I have 2 times 1 times 2. So 6 of these nitrates. Let's put a 6 in front of the potassium nitrate. Balances the nitrates, 6 potassium atoms. Let's put a 2 here. That gives us 6 potassium atoms, 2 phosphates. That's okay, 2 phosphates here. So this is the balanced molecular equation. Now we need to write the state for each substance. Potassium compounds are very soluble, even though phosphates in general aren't. But we have potassium, so we're going to say this is soluble, if you know your solubility rules. Nitrates are very soluble. That'll be aqueous, break apart into its ions. Another nitrate, aqueous, dissociate into its ions. And then phosphates in general, they're not soluble, except for potassium, maybe sodium phosphate. So this phosphate here, the copper 2 phosphate, that's going to be insoluble. That means it's going to be a solid. It's going to fall to the bottom of the test tube as a precipitate in this precipitation reaction. So we have the states. Now we can split the strong electrolytes into their ions. That gives us the complete ionic equation. Potassium's in group 1. That'll be 1 plus. The whole phosphate, that's 3 minus. So 2 times 3, 6 potassium ions. I won't write the states. Let's do that at the end. Plus 2 phosphate ions. Then copper, we don't know its ionic charge, but we do know that the whole nitrate is 1 minus. Good one to know. 2 times 1 minus, that's 2 minus, so the copper has to be 2 plus. So this is the copper 2 ion, and actually we have 3 copper 2 ions, and then 3 nitrates times 2, 6 nitrate ions. So these are the reactants in our net ionic equation. For the products, we had a plus and a minus, so 6 potassium ions, just like in the reactants, plus 6 of these nitrate ions, again, like the reactants. And then we don't split solids apart in net ionic equations, so we just have our Cu3PO4 2, we keep it together. So at this point, we can cross out the spectator ions. They're on both sides of the complete ionic equation. We have in the reactants 6 potassium ions here, and in the products, we also have 6 potassium ions. Looks like we have 6 nitrate ions here in the reactants, and then in the products, 6 nitrate ions. What's left, that is the net ionic equation for K3PO4 plus CuNO3 2. I'll clean it up, write the states, we'll have our net ionic equation. So this is the balanced net ionic equation for potassium phosphate plus copper 2 nitrate. You can see charge is conserved. 2 times 3 minus, that's 6 minus. 3 times 2 plus, that's 6 plus. They add up to a net charge of 0. This is neutral, net charge of 0. Atoms, if you look at those, they're also balanced. Often the positive ion is put first in net ionic equations. It doesn't really matter. Maybe it looks a little bit nicer. But that's it. This is the net ionic equation for potassium phosphate plus copper 2 nitrate. And this is Dr. B. Thanks for watching.